This video is for showing you how to use gaussEP. I'm going to show you by means of an example. gaussEP is good for calculating the uncertainty in a calculated quantity based on quantities whose value and uncertainty are known. So in this case, I'm calculating E is given by this formula, where M has the value 0.505 kilograms and the uncertainty 0.8 kilograms. And then the V, I got value and uncertainty. Same thing goes for the G and the H. So I've gone ahead and plugged in values for the expression and calculated the value of E, but gaussEP is for getting the uncertainty in that value, which clearly is going to depend on the uncertainty on the input values that you use. So we use gaussEP to calculate that uncertainty. I'll go ahead and locate it. I'm going to go Google CB Physics. Go to first semester downloads, math resources, gaussEP. Okay, double click. And first thing, it's asking me to type in my name. Go ahead and do that. Then here's the idea. gaussEP has the thing you're calculating there, how many variables it depends on there, and then the individual variables are the x1, x2, and x3 here. In our case, it's set by default to 3 variables, but we've got M, V, G, and H. That's 1, 2, 3, 4 variables. M appears twice, but it's just 1 variable. So I got to change that 3 to a 4. We're calculating something called E for energy, not F. So I can change it there, and I'll double click on this one and change it there as well. Hit enter, and now I'm ready to go to the next variable. Well, that's what I was calculating. I'll go to the first variable that it depends on. My first variable there was M, so I'll change that symbol to an M. I'll change it there, and down here that M was 0.505 kilograms plus minus 0.8. So 0.505, 0.8. The value 0.505, the uncertainty 0.008. Move on to the next variable, x2. Here, that's V. My second variable that I'm using is V. So V, return, the values of V were 14.25 meters per second plus or minus 0.20. So 14.25 and 0.2. 14.25, 0.2. That's V, and I forgot to change the name of it down there. I should change it in both places. There we go. Move to the next variable. I'm working on G. Happen to remember this time. So G was my third variable. The value 9.80399. 9.80399. The uncertainty 0.00005. 0.00005. Alright. Next variable is H, the height that the thing was above ground level, or above the reference level. Change it both places. The value of H is 0.577 plus or minus 0.01 meters. 0.577, 0.01. 0.577, 0.01. Hit enter. Now I got to type in the formula used to calculate E right at that location. I start with an equal sign. Say it's a formula. And it's equal to 0.5 times, the time symbol is the asterisk, and it's 1/2 mv squared. So I'm doing this part, 1/2 mv squared. I use 0.5 for the 1/2. Now I got to type the m in. To get the m, I go to the space that's the spreadsheet element that's got the value of m stored in it, and I click there, and it puts it right into my formula. See how the formula is coming along? 0.5 times m, and then times, obviously it shows a little bit more than m. It's saying 0.5 times whatever is stored in this cell of the spreadsheet, not element, but the cell. And then I got to go times v squared. It's 1/2 mv squared, so I got to get v in there. The value of v, really the location of the value of v, and then to the power of is the shift 6 key. Looks like an inverted v, 2. So that's the 1/2 mv squared, and now I need plus mgh. So plus mgh. I'm working on this formula right here. It goes plus, and then m times g, and then times, that's that asterisk, h. And I'll go ahead and hit the enter key. So I've got the formula calculated, and it's saying it's having a hard time doing it. I'm going to open up the space a little bit here. See, yeah, there's some mistake in there. So it's equal to 1/2 times m times v squared plus m times g times h. I think I put the letter h in there. All of them end in a 2. So when I clicked on h that last time, it's pretty clear that I clicked up here when I really needed to click here on the value of h. But I fixed that by changing that to an A2 at the end. So it's all set. See how it ends in A2. And now it's able to calculate a value. Not only that, it's the same value that I got here. So gaussEP calculates the value as well as the uncertainty in it. Okay, now what I got to do is copy this value down to all these locations. Copy this expression, I should say. So I'm going to go Control C, or I generally go Control C, but you can go paste. I'm sorry, copy to the clipboard. So you can use the editor keyboards if you want. I'm going to use you can use the menu items if you're familiar with those. I'm more used to the keyboard. Control C copies it to the clipboard, and I want to paste it to all these elements. To get to them all, I click on the first one. I just need to select them. Shift, that is, hold down the Shift key and click on the last one, and that selects them all. And then I do a Control V, and that copies the formula to each of those locations. You can check it out. It's not just the number that's there, but it's the same formula, except using A7. In other words, for instance, for M, it's using this value instead of this value up here. It's using this one instead of that one. Alright, the next thing I got to do, read this in yellow, change the worksheet names and red entries, see the about, tells you how to do it. After making the changes, press F9 on a PC, which is what I'm using Windows. So I'm going to arbitrarily click on that first element, but the key point here is to press F9. And all these values get recalculated, and you'll see that they're in the ballpark there. And then down here is the answer. When you use gaussEP, I always want to see the printout associated with it. First off, can't read these numbers, and I do want to see that one. So let's see if we can format the axis, the number. I'm going to find out how to change the angle that number makes. It's over here with the alignment, text direction. I'm going to try, let's see what 60 degrees. Yeah, let's say 45 degrees looks like. Okay, so I can read the numbers if I put them in at an angle like that. So you got to complete your work, you select everything from the upper left hand corner to down here. I'm going to shift click right there where the cursor is, and then print the selected item. Before you print, you should probably check with the lab instructor the first time you print, because otherwise it's going to print a whole bunch of stuff that you don't need. You know, all these numbers down here, for instance. So where's the answer? Is right here, standard deviation. So our answer is the energy is 54.16 joules plus or minus 1.649 joules. So quite a bit of error in that answer based on what went into it. Let me show you what the idea here is. For each variable, actually when you do the printout, I do want to see those guys, make sure that you got the right values in. So when you do your printout, get down to this corner. So print out all of the values that you used here. So this tells me the G that got used with the mean and standard deviation associated with this distribution. Let me show you what the idea is. For each one of these variables, gaussEP calculates 1,000 values of M such that the distribution of values will have the mean of approximately the value you typed in. Since it's using a random number generator to do it, it's it shouldn't really come out perfect, but it should be very close to the value that you typed in. I typed in 0.505, and that rounds to 3 sig figs to 0.505, but it's actually slightly different than that. It creates this random distribution of values. It's not completely random. It's a Gaussian distribution that has the mean that you typed in, and it has the standard deviation that you typed in, roughly. Because it's using a random number generator, it shouldn't come out exactly, but we typed in 0.008. It's coming out 0.079. Same thing for H. And I'll go ahead and check and make sure I get the right values. When I look at yours, if you get some very wrong answer, this is what I'm checking. I'm checking to make sure you typed in the values right. So 0.577, we actually typed in 0.577, but there is a little bit afterwards. But that's the idea. It should be close but not exact. And then 0.01, 0.0095. 9 rounds to 0.01 if you just keep 1 sig fig. So that's the right idea. And then we had V, 14.25. I remember that one, plus or minus 0.2. So that's good. And G, 9.8 plus or minus 5 times 10 to the minus 5th. That's very close to what I typed in. So for each variable that you type in, it generates 1,000 values using a random number generator, but the values are designed to conform to a Gaussian distribution. By the way, this bar graph, how high this one up tells you how many values were between whatever this value is and that value. One could read it if we blew that up, but we don't need that. But that's the idea. And then it goes and calculates the formula 1,000 times, it picks a value from here, a value from there, a value from there, a value from there, calculates it once, and then does it again and again and again. So you get 1,000 different values for the answer. That's what these are. And then we calculate the distribution for it. In other words, find out how many values fall between one value and the next value, and that generates one bar of the bar graph. Do that for all these intervals, and then fit a Gaussian curve to that distribution. And the width of the Gaussian curve tells you what the error, the center point tells you the mean value. Again, we use randomly generated values, so this actual mean, I suggest when you record your result, you use this value, which is calculated exactly just like you did it using a calculator, or I did. But this one should be very close to it. So 54.16 is indeed close to 54.13, especially considering that the error occurs in the ones place. So the uncertainty is 1.6. So in other words, that 4 isn't even certain. So this is appropriate for the mean, an actual mean of randomly generated values, and this is the standard deviation, what we're going to record as our uncertainty in the value for E. So you should then copy that to your paper. I'm not going to because I'm on the computer here, but we've got plus minus 1.6. It would be sufficient to call that 1.65, round it to 3 sig figs. So you'd say the answer is 54.13 joules plus or minus 1.65 joules. Write that in there where the question mark appears. And that's how you would use gaussEP to determine what the uncertainty in a calculated value is. That's it for this flick.